We're here at the China and East Poland rocket launch party with some fans, friends and family, and there's Dave fixing the rocket, and Nick is ready to risk his life to hold the launching pad. He is risking his life. And
push it right now.
This is taking longer than expected. My arms are getting sore.
So are you doing multiple launches?
We could potentially do multiple launches if it doesn't explode on the first one.
Fire in the hole! Fire in the hole!
Do a countdown, Dave. Should I start from 10 or 3?
5.
5, 4, 3, 2, 1. Let's go!
Heads up!
Here we go on the second launch of the China and East Poland rocket. On the first one, it was very successful, going straight up, but we also did point it quite straightly. So this time we are going to point it at an angle and see if the software will self-correct itself in time. The fans have all relocated to the same side, away from the rocket launch. Okay, here we go. Check out that angle. That is quite an angle.
It should go straight up.
5.
Probably won't.
4.
Hey, count it in Chinese.
Why?
2,
Wait.
1. Hey! It pretty works!
Where is it? Where is it?
It doesn't work though to parachute still.
On the third launch, we are aiming for the goal post. That's right?
Go! Holy crap, it worked! Wow. Come on, parachute! So it takes about 3 or 4 seconds to calibrate. So it reads the values off the gyro for a few seconds just to zero it. And then from then it tries to compensate for this direction and like all these directions, but also if you twist it, all the fins turn in the opposite direction to try to compensate.
How did the integration on the gyro not end up adding to a bunch of error?
It does, just takes a couple minutes. Yeah.
So you can't plug it in for too long.
Yeah. So I guess I'll open it up so you can see what the internals are like.
Interesting. The Patriot missile in the 80s had the same problem because of rounding errors.
Really?
Yeah.
Huh. Well, you were dealing with a lot of that because there's no SPU on that, right?
Yeah, exactly. Yeah. Although the floating point stuff that they do is actually pretty good. So, like it's all like I guess fixed.
Yeah, fixed point.
But they do a fancy bunch of fixed point stuff to make it somewhat standard results.
Okay.
So it's actually surprising how well it works, and it's really slow, like order of magnitude or more slow. So this thing's probably like maybe 60 hertz or something like that, whereas it should be like 600.
You're opening a hatch, aren't you?
I put a lot of tape. This tape is very structural.
Held together by scotch tape.
Yeah, exactly.
Well, at least it's not duct tape. Well, actually duct tape.
Duct tape is better, yeah.
Duct tape might be better in this case.
Heavier though.
Is this paper tubing?
Yeah. Do you feel nervous with it pointing at you?
There's no engine.
How confident are you that that engine is fully spent?
Not at all. Why? Oh, it's
Disarmed.
Does anybody have a knife?
That smells kind of
Yes,
good.
actually.
It's gunpowder.
I have a little knife. Well, this sort of.
Right, there you go.
Oh,
Yeah, okay.
just gonna use my knife.
Oh,
Oh.
actually, no, bring your knife here. Here.
I don't know. You didn't want
Slam
my
it up. Slam it up. And cut that little piece there.
Don't break
on
his
a rocket.
thingy.
It's already
You're
broken.
Rocket. Yeah, that's good. That's good.
Rocket surgery.
So, here's a little,
You're a rocket surgeon.
little tiny battery. So adorable.
Cool.
1 cell.
2.
Oh.
And then this thing is a little power regulator. It's like just to get 5 volts out of it. And then here is the Arduino that's all packed up inside.
Wow, that thing's tiny.
So this is an Arduino.
Arduino board?
Yep,
Wow.
it's an Arduino Nano. Atmel
Okay.
328. This is the breakout board that has the accelerometer and gyro.
Okay.
It's got all that junk on it. I'm only using the gyro.
Yeah.
It even has pressure sensors, so I could have told like how high it went,
Yeah, okay.
which
okay.
would have been cool, but I didn't collect any data, so.
Yeah.
Is there any flash on it for like logging or anything?
There's I think 2K of EEPROM or something like that, so
That's a lot.
it can be alright. Yeah, so
you go.
it's alright. And so this thing here is actually like, all this is kind of cool, I guess, but my like pride here is like this little brass fitting in here. Look close here. I don't know if you can see it.
Oh, up top here where the fins
Yeah,
are.
so it's like a brazed piece of brass with some brass tubing and then smaller brass tubing to like make the little joint.
That Dave made himself.
Okay, and then the little actuators are just mounted on the inside of the tube.
Yeah, exactly.
How'd you make it?
You take a piece of like sheet brass and then you fold it over to a circle, heat it up with a blowtorch and put some solder on it and just kind of goes seals it.
Cool.
So on and so forth. And I did this all with like a drill, like a hand drill.
Holy crap.
Yeah, sounds great.
Great.
Sounds like a robot.
Yeah.
Exactly.
So satisfying.
And then this is a garbage bag.
That's why I didn't open it all.
And I was a little worried that the math for 3 fins wasn't going to work, because like if it overcompensates on one side, then it'll start spinning and stuff, and it'll be all wonky and whatever, but it seemed to work really well.
How did you test the software?
We just
I
did, you
held
just
it in
saw
my
it.
hand, and then I did this.
And you just saw the fins move and you're
That
like,
looks right.
the map's correct.
That looks right.
That's
yeah.
pretty impressive.
That's called DLAR engineering.
Without having a wind tunnel, that's probably about as...
Well, honestly, our testing was just now.
We were thinking about
First and
holding it out the
second
window
and third.
while driving
Oh, yeah.
as a wind tunnel.
That's called taxi test. Wait, that's not.
And if you zero it and hold it, it shouldn't want to try to veer off zero
Exactly.
at least.
Or
yeah.
if you try, although the problem is like you can't really test two of these big fins at the back because it's always going to want to try to equal it anyway. So
Yeah.
I didn't know exactly how I would test that. So
Okay.
I just
Science.
thought, F it, launch it and see what happens.
Are the larger scale ones usually like steered at the top or near closer to the nose cone, or is it closer to the actual thrust?
Depends on what the center of gravity of.
Yeah, I guess that would make
So yeah,
sense.
this
eh?
actually, the reason I did this is because the fins are actually at the bottom before, and you can see like the blue
Yeah,
marks.
yeah, yeah.
So I moved them all to the top, basically as far away from the center of gravity as possible, and then it really simplifies the math because all you have to do is aim this, like for every angle you get, or every degree you get off axis, you aim this up a degree plus 10%
Yeah.
or something like that. So as long as it's pointing straight up plus a little bit more,
Yeah.
you know it's about right.
Yeah, makes
So-
sense. Makes sense.
Because if it's a little too, like if it's less, then it'll never reach that
Yeah,
maximum
exactly,
angle.
yeah.
So like it won't asymptotically meet where it's supposed to go. So science.
Yeah, science, exactly.
Wow.
Science.
Geometry.
That's what you're learning for your MCATs, isn't it?
Cute.
So I think I might have to like
Can help me with
permaplaque
the
this or
rocket
bronze it or something.
Yeah.
Just
I
as
think
it is.
I think that deserves to be mounted somewhere, like with a plaque.
You take a picture of it and superpose it with all the different rockets. You know, they have like the different rockets that have been like throughout history.
Yeah,
Like
and then-
space shuttle, just, like, crackers
The
off
Saturn
thing at the
V
end.
moon
It's like,
rocket, and then there's
Dave, did you name it?
it's called Centauri.
You sure it's not Dave 1?
Rocket ship 1. No, spaceship 27. Yeah. Yeah. That's it. Science.